STAM is a small engineering company based in Geneva, Italy. It provides engineering services to industries operating in various fields, such as space, automation and robotics, transport and energy. Since 1997, STAM has developed power transmission systems customized to user needs. One of the transmission systems invented and patented by STAM is the new gear, which stands for nutating gearbox. This mechanism has several advantageous characteristics. It is very compact due to only having 3 moving parts, and it resists overloads and shocks very well. In order to obtain such advantages, the development of each model requires several design and engineering steps and a costly production.
The
design of the gearbox starts with the selection of its main parameters, which allows us to set the conceptual design of the main components of the gearbox. As soon as the concept is verified and it meets the specifications, the gears are designed and the technical drawings prepared, where geometrical and dimensional tolerances are prescribed.
Thanks to the design and analysis tools developed in CAxMan, the designed gearbox is modified, adding internal structures that will be 3D printed. Mechanical simulations are performed to verify the resistance of the design. A small layer of extra material is added to the parts design. It will be machined to reach the required precision. Then thermal simulations are performed to verify the printing process. Prior to the actual printing process, the model is orientated, the support structures are created, and the model is divided into layers. The exchange of information among all these steps benefits from the interoperability of step data format. The next phase is the part printing or additive manufacturing. This phase is done by Tronrud, a medium-sized engineering company based in Hønefoss, Norway. Tronrud have made metal additive manufacturing parts since 2011 and have more than 20,000 machine hours on their EOS powerbed machines. In 3D printing, the metal powder is melted by the laser. In the new gear case, a high-performance steel alloy is used. The powder that was not melted is then removed and the required part is obtained.
For us,
CAxMan is an opportunity to get useful analysis tools that improve the part design and optimize the additive manufacturing process. With CAxMan tools, both our designers and customers can simulate the process and validate their design. To get a good result, it is important to design the part to suit the additive manufacturing process.
The dimensional control step is done by Trimec, a leading company in the Spanish market in the field of coordinate measuring machines and measuring and digitalization software. After printing, the parts are 3D scanned to check that the additive manufacturing has produced a compliant part. The parts are then milled to obtain the required smoothness and precision, before being scanned a second time to check that the geometrical and dimensional tolerances prescribed in the design phase are fulfilled.
Thanks to the CAxMan project, we've been able to learn how to properly analyze complicated workpieces produced by additive manufacturing. Using a non-contact 3D scanner, the workpiece is scanned in order to check whether the established requirements are met through different graphical representations.
To finish the parts, the extra material that was printed is cut away, obtaining exceptionally smooth and precise surfaces. Finally, the mechanism is tested in the laboratory to assess its efficiency and the quality of the transmission. Thanks to the additive manufacturing process and the CAxMan tools, the production of the new gear parts is 40% faster and 20% cheaper. The parts are 25% lighter and the design process is 15% faster. These are major advantages not only for STAM but also for the users of the gearbox. Similarly, any user of the CAxMan technologies can improve their own design, engineering and production processes.